Hi everyone, today we're going to be spending a second day on graphing polar systems, except today we're talking about systems, not just regular equations. We're also going to be solving these polar systems algebraically. So let's take a look. Systems of equations can be used by the polar world. I know you guys are all wondering who that gentleman is on the back of the slide, so in honor of President's Day being in February, that is a past president. The first person from the class who emails me the correct answer gets extra credit, but don't waste your time doing it right now. Get your notes done and make sure all of your notes are in your notebook, so when I check them on the next day, you will be getting full credit, and make sure you get your homework done as well. So, taking a look at systems of equations, as we found out in the XY axis world, were two or more equations that we could solve algebraically or graphically that had two variables. We also used matrices to help solve some of these systems of equations with 2 or 3 variables. So we can find these solutions by doing a couple things. We can use substitution. We can use elimination. We could use matrices. We're not going to quite focus on that right now. And we could graph them. But all of our solutions had to be ordered pairs because each of the equations looked like 3x minus 2y equals 12 and 4x plus 3y equals 6. So they both had two variables, so our solution was the ordered pair xy. Today, our polar equations are going to be r, some form of theta, and another r with another theta. So it's going to be an ordered pair of the radius and the degree for each of these. So let's take a look at an example. We've got r equals 2 sine theta and r equals 2 times 2 theta. So we're going to solve it algebraically first, and we're going to be looking at this. This is a double angle, one of the ones that we've talked about 2 chapters ago. So we need to remember our double angle formulas. Those do not go away. So the sine of 2 theta can be substituted by 2 sine x cosine x. And we're going to solve this algebraically. Since both of the equations are equal to r, this sets us up for a really easy substitution. So instead of r, I can write 2 sine theta equals 2 sine 2 theta. And here we want to do some substitution because I want to get rid of that sine 2 theta. So 2 sine theta equals 2 times, replace 2 sine theta or sine 2 theta with 2 sine theta cosine theta. So do some multiplication for sine theta cosine theta, and these problems should look pretty familiar since we talked about these when we were solving trig equations. We want to be able to solve for theta, so we want to get it down to at least one trig function equals a number if that's possible. So I notice there's a sign on both sides, so I want to get like signs together, and my operation to do that is with division. When I'm dividing by the sine of theta, it cancels off on the right side. It also cancels off on the left side. So that deals me one answer. I need to look where the sine of theta equals 0. And that happens a couple different times. So theta is the sine inverse of 0. Well, draw a quick sine function. That happens 3 times between 0 and 2 pi. That occurs at 0, pi, and 2 pi. And we're going to come back to this in a couple minutes. Let's keep solving our problem over here. 1/2 equals the cosine of theta. So now my answer is down to one trig function, so I can take the cosine inverse to solve for the angle. So the cosine inverse of 1/2 equals our theta. So cosine is positive here, so all students take calculus. I want to find where it's a half. So that's going to occur here and here at pi thirds and 5 pi thirds. So those are 2 more answers for my theta. Pi thirds and 5 pi thirds. Like we said earlier, when we solved systems of equations previously, we had to find an ordered pair, and that's the exact same thing that we're doing, our ordered pair r theta. So we're going to plug in each one of these thetas into one of our original equations and find out what our r value is. So we've got 5 different points that we're going to check. So 2 times the sine of, instead of theta, we're going to replace that with 1, 2, 3, 4, 5 different numbers. So 2 times the sine of 0. Oops. So the sine of 0 is 0, so my r value is 0. R equals 2 times the sine of pi. Well, the sine of pi is 0, so r equals 0. R equals 2 times the sine of 2 pi. That again is 0, so r equals 0. Now I want to plug in pi thirds and 5 pi thirds. So r equals 2 times the sine of pi thirds. So the cosine of pi thirds was 1/2, so the sine of pi thirds is the square root of 3 over 2. So my r value is the square root of 3. Let's try the other one. R equals 2 times the sine of 5 pi thirds. 5 pi thirds is in the 4th quadrant. Only cosine is positive down there. So I get 2 times negative square root 3 over 2. 2's cross off, so my r is negative square root 3. So my solutions are 0, 0, 0 pi, 0, 2 pi, square root of 3 pi thirds, and negative square root of 3 5 pi thirds. So I've got 1, 2, 3, 4, 5 points of intersection. So let's just double check that on our graphing calculator. Get your graphing calculator on. Make sure your modes are in radians and polar, and go to your y equals. Plug in your 2 equations. Oops. 2 times the sine of 2 theta, and graph it. And that's what our graph looks like. So we can see we've got 1, 2 very evident points of intersection, and down here we've got 3 points of intersection rolled into 1. So we can use our trace to go along and figure out our points. With the polar functions on your graphing calculator, there is no way to calculate our point of intersection, so we're just doing it by trace. Our other option is to look at our table and see when it equals the exact same thing. All right, so we're going to take another stab at one of these. So here's our new system of equations. R equals 3 minus 3 sine theta, and r equals 4 minus 4 sine theta. So again, very nice because it's set up very easily for some substitution. So 3 minus 3 times the sine of theta equals 4 minus 4 times the sine of theta. And obviously there's a couple different ways you can approach this problem. It's up to you what you want to do. I am just going to subtract 3 and add 4 sine theta both sides. So these are going to cross off. These are going to cross off. Over here, I've just got the sine of theta, or 1 sine theta, equals 1. So I am taking the sine inverse of 1, and that should get me my theta. So I want to look at the places where sine equals 1. So there's my sine function again. So my theta is going to equal pi over 2. So I want to take that number and plug that in. I want to find all the places where this is true. So plug our theta into one of our two original equations. R equals 3 minus 3 sine, and our theta is going to be pi over 2. So my R equals 3 minus 3 times 1, because I can replace the sign of pi halves with 1. So R is 3 minus 3, so my R is 0. So now that I have my R and now that I have my theta, I can write the solution as an ordered pair. 0 pi halves. So that's the solution, the point of intersection, as I've solved algebraically. So let's take a look at that graphically and plug in 3 minus 3 sine theta and 4 minus 4 sine theta in our calculator, making sure we're in polar form and in radians, and press graph. And as you can see, we have two beautiful cardioids that intersect at 0 pi halves. We can also tell they're cardioids based off our equations. We've got 3 minus 3 sine theta and 4 minus 4 sine theta. They both have the same number in these positions, so that makes it a cardioid and not a le maçon. So our solution, again, is 0 pi halves. So this is what you're going to be doing for homework today. Please work with your groups. Make sure everyone understands it. If you've got questions, please visit the Math Study Hall and we can answer some more questions. Please make sure when you're doing this assignment that you are graphing these, not sketching these. Use your table function in your graphing calculator to help you graph these if you need some help. But do not just simply sketch on the paper. If you need more graph paper, it's on the front podium. And I will see you guys tomorrow.